So this is what is given in the first question, that if a charge like a positive charge kept midway between two equal negative charges, which way we can move so that the object or this charge will try to be stable. See, these two charge magnitudes, these two charges are equal and opposite, and the force between these two charge will be in this direction, force between these two charge will be in this direction, and because these two distances are equal, these two charges are the same, then this force and this force will be equal and it will not change. If you move this charge slightly to the left, what happens? This distance decreases, then this force increases, whereas this distance increases, this force decreases. So the tendency to bring this charge to this side will decrease, but the tendency to move it to this side will increase. So this will move in this direction. On the other hand, if you try to move the charge slightly to the right, this force of attraction between these two will decrease, this force of attraction will increase, and the charge on this hand, it will try to move this way. Hence, moving either to the left or right is not the correct option for us, so that it will upset the equilibrium or it will upset the stability. Then the charge will begin to move either to the left or to the right. But here, on the other hand, if you have the same two charges and this charge positive charge, if you try to move this charge slightly up, like in this direction, what happens? The force of attraction between this positive charge and this negative charge will be in this direction. This force of attraction will be in this direction, and these two are same, because the moment if you move this, these two are at equal distances from each other. Then if its magnitude is f, its magnitude will also be f. Unlike the previous case, when you move either to this side or that side, it will decrease the distance between one of the two charges and increase the distance between the other. But here, when you move this way perpendicular to the line joining the two charges, the distances will remain the same. So minus q to plus q, this minus q to plus q will remain the same. Then the force will be equal. Then this force can be resolved into two components. For this force F, there is a horizontal component and there is a vertical component. Then for this force, there is a horizontal component which will act against this, and there is a vertical component. You see, their vertical components are act along the same direction, but their horizontal components are acting in the opposite direction. Because this force and this force are equal, and this horizontal component and this horizontal component will be equal and opposite, so they cancel each other. Then the resultant vertical component will act on the charge towards the initial position of the charge. So when you try to move this way, it will try to, this vertical force will try to bring it back to the original position. If you try to move this way, it will try to bring it back to this way. Hence, this will be a more stable direction. Suppose if you move either to this side or this side, the charge has a tendency to come back to the original position. Hence, the charge stability will not be upset much if you move either to this side or that side, which means that our option B, like B1 to B2 direction, this is a B1 direction, this is a B2 directions, are better, so that if you move this way or this way, the charge will try to come back to the original position, and then this kind of moment is more stable.